We're now on screen 16 of 23. So here, this is where we start guided instruction. So you're going to be following along by writing notes on your sketch pad or into the text box here. And write down any questions that you might have so that you can ask them in class. So this first question says, here are two equations based on the information from the table. We have log base 10 of 100 is equal to 2. Let me highlight that. So that's that equation, and we can see it here in the table. And then the second equation is log base 10 of 1,000 is equal to 3. So you're probably wondering, what does log mean? What does 10? What does 102 mean? So that log is telling us what exponent to raise our base to. What exponent to raise the base to. This 10, that's a subscript, it's written a little bit lower, is our base. So we have a base of 10. This 100 written next to it is what our equation is equal to, what it's equivalent to. And this 2 is our exponent. Okay. So if I was to rewrite that, log base 10 of 100 is equal to 2. I can rewrite that as saying my base 10 can be raised to the power of 2 and be equal to 100. So basically 10 times 10 will give me 100. So that's true. That equation right there is true. 10 to the power of 2 is equal to 100. So the 10 is the base, the 2 is the exponent, and 100 is what it's equivalent to, what it's equal to. Okay, so the second equation, log base 10 of 1,000 is equal to 3. Another way of writing that is by writing my base 10 to the power of 3 is equal to 1,000. Or 10 times 10 times 10 is equal to 1,000. Okay? So that's how you read that table. And so if we look at these questions, right, or this question right here, it says what values could replace the question mark in these equations to make them true? So we have log base, it's already written. So we have log base 10 of 1 million is equal to what? So if I want to rewrite that, I can write my base 10, I don't know what my exponent is yet, it's a question mark, is equal to 1 million. Okay, so if I want to find out what makes this equation true, I have to think about what can I use as an exponent to get 1 million. And I can either look at this table. So let me look at this table. One way of solving this or figuring it out is looking at this table. So this table actually only goes as high as 10,000. So 10 to the power of 4 is equal to 10,000. If I multiply another 10, multiply 10,000 by another 10, I'll get 100,000. So not there yet, but if I multiply by 10 one more time, so a sixth time, then I will get 1 million. So if I raise 10 to the power of 6, I will get my 1 million. I wish I had $1 million. So this question mark in part A is 6. Another way that you can have figured that out besides looking at that table is to count the zeros. There are 6 zeros. So if I raise 10 to the power of 6, which is my answer, I will get 100,000. Or sorry, 1 million. So 10 to the power of 6 will give me 1 million. I'm going to erase these notes that kind of went into my next question. So remember, you can pause the video and rewind if you need to. I erased those notes right now because they kind of went into my next, the space that I'm going to write into next. So for part B, we have log base 10 of 1 is equal to question mark. So again, I have a base of 10 raised to the power of something is equal to 1. So I want to know, what does the question mark equal? What could I plug in as an exponent? What can I raise 10 to the power of to get 1? And again, I can look at my table. And I know that there's a 10 and a 1 in the table right here. So I want us to take a look at that really quick. So if we have this function at the top, log base 10, and then we replace that x with a 10, that is equal to 1. Another way of writing that is 10 to the power of 1 is equal to 10. So that won't give us the answer to problem 1b, because we want to know 10 to the power of what will give us 1. So this doesn't work. But if I do look at my table, I want to know if I plug in a 1, what would my exponent be? And the table only goes as low as 2, but it is close. And we can see that the exponent to get 2 would be 0.3010. So it has to be something slower than that. And if I actually think about my exponent rules, anything to the power of 0 will give me 1. So 10 to the power of 0 is going to give me 1. Okay. So then problem 1c, log base 10 of the question mark is equal to 4. So this time the question mark is in a different spot. So 10 is our base, 4 is our exponent, and we want to know what is that equivalent to. 10 to the power of 4, what is that equivalent to? So I can actually multiply 10 times 10 times 10 times 10, or I can look at my table right here and see that 10 to the power of 4 is 10,000. So you can pause the video here, add any last minute notes, write down any questions that you have. This is now screen 17 of Desmos. We're continuing the guided instruction. So question number 2 says, between which two whole numbers is the value of log base 10 of 600? Be prepared to explain. How do you know? So basically, we want to know what exponent can we raise 10 to get 600. So if I want to think about it this way, 10 to the power of 2 is equal to 100. 10 to the power of 3 is equal to 1,000. And 600 is between 100 and 1,000. So the exponent that I would raise 10 to get 600 is between 2 and 3. Okay? If I want to explain this with my words, I would say, let me write it here. The log base 10 of 600 is between, I can write that neater, between 2 and 3. the log base of 10, the log base 10 of 600 is between 2 and 3 because 10 squared is equal to 100 and 10 cubed is equal to 1,000. 600 is between both of those values. So the exponent must be between 2 and 3. And then if you want to shorten this, you absolutely can, but that's just me explaining it in my own words. If you think you can explain it in your own words shorter, or maybe even in a longer way, you go ahead and do that. So then the third question says the term log is short for logarithm. Discuss the following questions with a partner, and we're not doing this with partners, sorry, and record your responses. What do you think logarithm means or does? So logarithm, this is what I explained at the beginning here on this screen. So the logarithm tells us what to raise the base to. So for example, if I was looking at log base 10 of 100 is equal to 2, this logarithm part right here is telling me what I can raise 10 to. So I can raise 10 to the power of 2 to get 100. So this first part, log or logarithm, tells us what to raise the base to. Okay? So if you scroll down, so this is still screen 17. If you scroll down, you'll see the next question. This is 3b. It says, next to log is a subscript, a number or letter printed smaller and below the line of text. What do you think that subscript tells us? So if I think again of my example from earlier, log 10 of 100 is equal to 2. This subscript they're talking about is the 10. Okay, so what do we think that 10 is telling us? That 10 is our base. So the subscript is the base. Okay. So then this next question, what about the other two numbers on either side of the equal sign? And then it says, for example, the 100 and the 2 in log base 10 of 100 is equal to 2. What do they tell us? So 100 is what the function is equivalent to when you raise the base to the exponent. So that 2 is the exponent we can raise the base to get a value. So 100 is the value, and we can raise the base to 2 to get that value, 100. Okay. So then we can move on to screen 18. So screen 18, I couldn't get it all in a screenshot. I think there's more options after E and then more after 5. But I'm only going to go over A and B with you. And then you're going to do the rest on your own on this screen, okay? So for each equation in the left column, so in this column here, find in the right column an exact or approximate volume for the unknown exponent so the equation is true. So if we're looking at A here, it says 10 to the power of y is equal to 10. So basically, what can I raise 10 to the power of to get 10? And if I raise 10 to the power of 1, I will get 10. So in this case, y is equal to 1 because 10 by itself is just 10. If I look at part B, it says 10 to the power of y is equal to 20. So what can I raise 10 to get 20? And if I think about it, well, 10 to the power of 1, we said that's 10. What's the next number? 10 to the power of 2 is equal to 100. So I am guessing that my exponent is going to have to be a decimal in this case. And I know that decimal has to be between 1 and 2. So if I'm looking at my options here on the on the right column, I have one option here, 1.301. And then I can't remember which option it is, but there's a 1.99 option also. So it's between these two options. It's either 10 to the power of 1.3 or 10 to the power of 1.9 will give me 20. And if I use the process of elimination, let's think about it. Is 20 closer to 10 or is it closer to 100? The answer is it's closer to 10. So it's not really close to 100. So my exponent must be closer to 1. Right? So I have 10 to the power of 1 is equal to 10. So my exponent to give me 20 has to be close to 1. And the only option that's given to me is 1.301. So B matches with 5. Let me draw those arrows a little bit bigger. So B matches with 5 and A matches with 3. You're going to go ahead and now do the same things that I just did for the rest of this screen, and then be prepared to work on some practice problems in class.